Here is the demo for distributed blockchain. We are showing here 3 copies of the blockchain. These copies are seen as peer A, peer B, and peer C. In reality, there are hundreds or thousands of copies, but for simplicity, we're only showing 3. All copies of the blockchain are identical. How can we confirm that they're identical? Well, if the hash value of the last block is the same across all copies or peers, that means that the chain is valid or unchanged. So this one is C719, if we ignore the zeros, C719, and C719. Let's try something. Let's try changing one of the blocks in peer A. So I'll go to block 3 and I'll remove transaction 2. Notice how this copy of the blockchain became invalid because the hash of these blocks isn't satisfying the leading zero condition. The hash of the last block in peer A is different from the last hash of the other peers. 0CCD is different than C719, which is found in peers B and C. So these two are the same. Let's correct peer A's chain by remining the impacted blocks. So I'll remine this, and I'll remine this. Even after remining, this hash is different from the corresponding hash of the other peers. See how these two are the same? C719, C719, and these two are different from the first one, which is FF59. By the majority rule, the blockchain copy of peer A will be outvoted and rejected and probably kicked out. So far, we have been showing fictitious examples as transaction 1 and transaction 2 for data. Let's take a look at how these transactions look in a relatively real blockchain.